Okay, so the first thing we're going to do on the review is we're going to classify the figures below as regular or irregular, convex or concave, and by the name. So if we're looking at the first one, if it's regular, regular means that all sides are equal and all angles are equal. So if you look at the sides, I know these two have 2 tick marks, this one has 1. So that means that this would not be regular, which means it has to be irregular. Then concave or convex. To find whether it's concave or convex, concave means that it caves in. So if you're going from one point or one vertex to the other, if you are outside the figure, like here, if we went from this point to this point, we would be outside our polygon that we're looking at, which means that it's going to be concave, because this side would cave in. Then, if we want to name it, we have to figure out how many sides it has. So if we count the sides, we have 1, 2, 3, 4, 5, 6, 7, 8 sides. So I know an 8-sided figure is an octagon. All right, then looking at number 2, we are looking to see if it's regular or irregular. So we see all the sides, because they have 1 tick mark, are equal. All the angles are equal, so this means this one would be regular. Then if I went from one point or one vertex to the other, I would stay on this line. If I went from this vertex to this vertex, I'd still be in the shape. It doesn't cave in anywhere where I would be outside the shape, so this means that it would be convex. And then lastly, we want to count the sides. So this has 1, 2, 3, 4, 5 sides, and a 5-sided figure is a pentagon. Okay, next let's look for the missing angles. And so in both 5 and 6, all my angles are actually outside these polygons. So I know that I'm looking at exterior angles. Okay? I have a bunch of them, so that probably means I'm going to use the sum. So if you remember from our lessons, the sum of the exterior of any polygon is going to be 360. So what I would do to solve for this, if all of these 3 should add to be 360, then I'm going to take the ones that I have, 82, 89, and 76, and I'm going to add those together. That would give me 247. So then I would take the sum of what they should be, which is 360, and subtract what I already have to get x. And so when you do that, you end up getting 113 degrees. Number 6 would work exactly the same way. Now, in number 7, we're looking at the interior this time. And so the sum of the interior angles formula, which you'll be given on your reference sheet, is going to be n minus 2 times 180. Remember that n is the number of sides, so I'd have to count how many sides I have. I have 9, so I'm going to plug 9 in for n, so n minus 2 times 180, that would give me 7 times 180, and so the sum would be 1260. Now I'm going to take each one of these angles inside, and I'm going to add them together to figure out what is left that x could be here. So I'm going to add all of these up, and when you do, you end up getting 1160. So we subtract that, and that means that our x is going to equal 100 degrees. Okay, so number 8 would be solved just like that as well. Now, we're going to do some of the word problems. So looking at number 9, it says find the measure of each interior angle of a regular pentagon. So each interior, the formula for that is, do you remember? No? N minus 2 times 180 divided by n, right? Divided by n. So here, our n is 5 because it's a pentagon. So we would do 5 minus 2 times 180, and then I would divide by 5. And so 5 minus 2 is 3 times 180, which is 540. I would divide 540 by 5, and that would be 108 degrees. Now, number 10 asks us to find the measure of each exterior angle of a regular 18gon. So each exterior, the formula for that, and you'll have to remember this, is 360 divided by n. So I know here my n is 18, so I would do 360 divided by 18. When you divide 360 by 18, each exterior measure would be 20 degrees. Okay, and then here they asked me for the sum of the exterior angles of a 40gon. Okay, so what you want to remember, when you see sum of the exterior, that's always going to be exactly the same thing. It doesn't matter how many sides or what information they give you after that. The sum of the exterior is always going to equal 360. So make sure as you're doing these problems, you're really focusing on whether they're asking you the sum or each, and whether it's talking about exterior or interior. Okay, so let's try 16 now. We're going to get into the area of polygons. So looking at 16, they want to know the area of this trapezoid. So our formula for area of a trapezoid is 1/2 times the height times base 1 plus base 2. Here, my height would be 9. It's always going to be this dotted line down the center. It does not matter which one's base 1 or base 2. It can be either. So the way you'd set this up is 1/2 times 9 times 8 plus 14. When you plug that into your calculator, that ends up giving you 99. And remember, we're multiplying two things that have feet, so it would be feet squared. Okay, then here they tell us the height of the parallelogram, or they want us to find the height of the parallelogram, and they give me the area. So we need this piece right here. The formula for area of a parallelogram is base times height. So if I plug in everything that I know, the fact that my area equals 198, I'm going to replace A with 198 equals my base. Here my base is 18 times my height, which I'm finding. To find the height, we're going to have to get the height by itself, so we divide both sides by 18. And so our height is going to equal 11 yards. All right, and so on 18, they're asking us for the area of a triangle this time. So the area formula for a triangle is 1/2 base times height. In this one, I know that 12 is my base, but I don't have my height here either. The key to this is the fact that this is a right triangle. So if it's a right triangle, we know we can use the Pythagorean theorem. So we would do a squared plus b squared equals c squared. I'm going to let our height be x, so x squared plus 12 squared equals 13 squared. That would give me x squared plus 144 equals 169. I could subtract 144, and that gives me x squared equals 25, which means my height is going to be 5. So now we're just going to plug in to this formula. Our area is going to be 1/2 times the base, which is 12, times the height, which is 5. I know 12 times 5 is 60, and 60 divided by 2 is going to give me 30 feet squared. Now, remember, I'm giving you all of these formulas except for the area of a rhombus or kite. So make sure that you know those. All right, so like in 19, we want to find the area of this kite. I remember, because these are the only figures that give you diagonals. So even if you can't remember the formula, if you look, there's these dotted lines going through the center, and they have numbers on them. So that should let you know, okay, I'm going to have to use those for something. And the formula is area equals 1/2 times diagonal 1 times diagonal 2. So here, I want my whole diagonal. So if I look here, I know from the last unit that this diagonal is bisected. So this whole thing would be 10. Then I have to find this whole piece right here. I know this piece is 16, but I don't know this piece. If you remember from the last section, I know that the diagonals form 90-degree angles. And so because of that, this makes this a right triangle, and I can use the Pythagorean theorem to find this piece right here. So when you plug in and you use the Pythagorean theorem, you'll find that this piece right here is going to be 12 meters. So that makes our diagonal 2 28 meters long. So when you plug into our formula, that ends up giving us 1/2 times 10 times 28. And when you plug that into your calculator, that gives you 140 meters squared. All right. So now let's look at some of the areas that deal with variables. So like in number 20, we're looking for the area of a square. I know the formula for area of a square is is side squared. So here, one of my sides is x plus 5. So the way I'm going to write this is x plus 5 squared. Now, I don't like leaving it like that because most of you would tell me that the answer to that would be x squared plus 25, and that's not right. So I like you to write it as x plus 5 times x plus 5, because squared just means that thing times itself. So once you write it like that, hopefully that reminds you that you need to use FOIL. So if I do my first times my first, that's going to give me x squared. Then I do my outer times my outer, so x times 5 gives me 5x. Inner times inner, so again I get 5x. And then last times last is 5 times 5 is 25. Now our last step to get our area is to combine our like terms. So I know 5x and 5x can be combined. And so our area would be x squared plus 10x plus 25. And so that would be your answer there. Okay, let's try one more with variables. So let's look at 23. In 23, we're looking for the area of a rhombus. And so the formula for area of a rhombus, again, you see these diagonals down the center, so you know you're going to have to use your diagonals to solve. So that would be 1/2 times diagonal 1 times diagonal 2. I want this whole diagonal here, and so I know this piece is 6x, and in a rhombus, my diagonals bisect. So if this piece is 6x, that means this piece is also 6x. So one of my diagonals is 12x. And then again, if this piece is 4x plus 8, this piece is also 4x plus 8. So my second diagonal would be 8x plus 16. So when we plug that into our formula, that ends up giving us 1/2 times 12x times 8x plus 16. So yesterday we talked about in what order we do this. You always gonna, since we're multiplying everything, we always want to start left to right. Just like you read left to right. When you solve, you go left to right. So the first thing we're going to do is we're going to multiply 1/2 and 12x. And I know that 1/2 of 12x is going to give me 6x. So I'm done with both those pieces. Now I need to bring down 8x plus 16. So then we distribute our 6x. We do 6x times 8x, which gives me 48x squared. And then I'm going to do 6x times 16, which is going to give me 96x. And that would be your answer. Next, I want to look at 27. In 27, they tell us the area of a trapezoid is 80 centimeters squared. The bases are 4 centimeters and 12 centimeters, and they want us to find the height. So the first thing that's important to us is the fact that we're looking at a trapezoid. Our formula for area of a trapezoid is 1/2 times the height times base 1 plus base 2. They give me the area, which is 80. They give me both bases, so base 1 I can say is 4, base 2 is 12, and they want us to find the height. So we're going to plug in everything that we know to this formula, and when we do, we would get 80 equals 1/2 h, base 1, which is 4, plus base 2, which is 12. When I add 4 plus 12, I get 16, so I get 1/2 times h times 16. Now, my 1/2 can be applied to my 16 because you can't really half an h, so we're going to apply it to this 16. And when we do, we get 80 equals 8h. Then to solve for the height, we want to get h by itself, so we divide by 8, and our height would equal 10 centimeters. Okay, the next problem I want to go over is a word problem. So we're going to look at 28. 28 says Sarah is making one of her spare rooms into a personal gym. The room is a rectangle with a width of 12 and a length of 14. What is the area of a room? So the first thing that we know that's important is the fact that we're looking at a rectangular room. They give us that the width is 12 and the length is 14. To find the area of a rectangle, we always do area equals base times height. Here it would be length times width. That's the same thing. So our area is going to equal 12 times 14, which means our area would be 168 feet squared. Part B asks, will she be able to fit the treadmill, weight bench, and stationary bike in her personal gym? So this is the area of her personal gym. Now I want to find the area of each three of these to make sure they would fit in this. So this is a rectangle, so we would do area equals base times height, so 15 times 4. And that would give us 60 feet squared. Then we would do the area of the weight bench, which is a triangle, and so our triangle is 1/2 base times height. So we would do 1/2 of 4 times 12. The area of that would be 24 feet squared. And then we would do the area of the stationary bike, which is a square, and our square is area equals side squared. So that would be 4 squared. Our area for that would be 16 feet squared. So now we would want to add all three of these up. And when we do 60 plus 24 is 84 plus 16, that would give us 100 feet squared. So that is less than 100 feet, so this would be a yes. Okay, let's try another one of those. Let's look at 31. So for 31, it says your friend decided to paint the walls of her room with a lovely lavender paint. She has $75 to spend on paint. Her ceiling is 21 1/4 feet high. Her room is a rectangle with two opposite walls measuring 11 1/2 feet and the other two walls measuring 20 feet. The first thing they want us to do is find the total area of all 4 of her walls and round to the nearest hundredth. So it said that her room is a rectangle. And they want us to find the total area of all 4 of her walls. So we're not just finding the area of her room, but of the walls. So 2 of the walls are 11 1/2 feet by 21 1/4, and then 2 of the walls are 20 feet by 21.25. So the way you would do that is you would do, remember area is going to be base times the height, so we would do the area of this, so base times the height, but we'd multiply it by 2 since there's 2 walls. So we would do 2 times 11.5 times 21.25. And then we would also do 2 times 20 times 2. And we would, I'm going to go ahead and we would add those together. together because we want the area of these two walls plus the area of these two walls. And so when you plug that into your calculator, that's going to give you 1,338.75 feet squared. Okay, then it says if a can of paint covers 400 square feet, how many cans of paint does she need? So we've got to figure out how many square feet, how many 400 square feet will go into 1,338. So we would divide the total area by 400, and when you put that in your calculator, it goes 3.3 times. You can't buy 3.3 cans, and so we would need 4 cans of paint. Then it asked me if a can of paint costs $17.99, will she have enough money to paint all 4 walls? So she started out with $75. So if she needs 4 cans and they're $17.99, then we're going to do $17.99 times 4, and that would give me $71.96. So yes, she'd have enough because it's less than she has, it being the price of the paint.